Hello. I have done my mechanical engineering from NIT Surat in the year 2011. Then, after I was placed in various organizations, I have been into the oil and gas industry throughout my career. But the roles and responsibilities were varying from fabrication to the EPC, that is engineering, procurement, and construction. Now to the Kent, that is one of the biggest, I would say, engineering consultant. They have moreover the orders from the say USA, Canada, because of the engineers we have. I mean, the capabilities with the new technologies we are introducing. We are getting into the green hydrogen as well as the sustainability fuel, that kind of projects. So we are into that. Basically, my role over here in Kent PLC. Formerly, this organization was known as SNC Leveling. It was
Okay.
taken over by Kent's. Now it has been named as Kent PLC. So from there, I am currently as a mechanical engineer looking for the feed front end engineering project. It is a phase of a project where we test the feasibility before the actual construction and the procurement of the items take place. See, once the estimation is with the client, and then they comes to know that this project is feasible to move forward, so then only it goes like a green signal from client and it goes to the construction part. But before that, we provide the feed report. Based on that, here again I would be looking after the static equipments, which are of non-fired equipments like heat exchanger, reactors, columns, pressure vessels, storage tanks, that I'm looking after. Based on the client specification, we provide the preliminary design, we float it to the vendors, and then vendor provide us the vendor offer. We have a round of technical queries, we prepare the technical bid evaluation, and then we provide all the information to the client. So that's how the role. See, if again I would be referencing to my static equipments mainly, the stainless steel is a very crucial material in terms of the properties it inherit, like corrosion resistant, strength, it has ductility, durability. Corrosion resistant is one of the key factor in oil and gas industry, because the crude which are coming, we do say it as a upstream. The crude is being taken out from the sea or the land from where they do the drilling part. From there, it goes to the refinery. Now, this crude has many, I would say, severe solutions including in them. I mean, the substance of acidic in nature, then the substance that contains sulfur, then the substance that contains the chlorine. These all are the factors that actually leads to the corrosion of the the material in which they are in contact to. Exposure of the material with the crude is actually lying to, basically it goes to the factor as a main corrosion, where we provide the now here the stainless steel plays a part, where the corrosion it will be acting as corrosion resistant. Why the stainless steel and not the carbon steel? Stainless steel is basically known because of the chromium, high content of chromium. At the normal temperature, when the stainless steel material is formed, the chromium formed an chromium oxide layer on the top of the stainless steel material. This actually prohibit of this sulfur or the chlorine and other acidic components to attack on the ferrous element, because this protective layer has been formed, and this is the basic function of the stainless steel. Because of that, the corrosion resistance, the longevity of the equipment or the piping increases. So it helps us in the design, where actually client wants that particular pipeline or that particular equipment needs more lifespan. They cannot afford to have maintenance or replaceability within a year or two. At that case, we use the stainless steel material. Yes, I will be covering in our discussion mostly austenitic stainless steel, which are
Okay.
the grades of SS 304, 316, 321, 347. But there are other stainless steel as well available in the market based on the factors and the requirements of that particular process. For example, if I may say martensitic and ferritic, they have their particular use based on the temperature and the corrosion resistant requirement. So
Right.
based on that, it has been used. But I would be talking more about austenitic stainless steel. The grade 304 is very commonly used, not only in the oil and gas industry, it is very well used in our kitchenwares as well. So that's the way. Generally, in our jargon, we use it as 18-8. 18% chromium is available and 8% nickel is there. So that's how we uh, use that. We are going to use 18-8 in this particular service. If I may, technology, what we are, I mean, if I would say that, see, stainless steel material, by making it, it becomes bit costlier, and our client is generally always asking for cost efficiency as well. So now what happens is one of the key parameters what we have looked after is that the equipments are being made of carbon steel, but it has the inner layer of the stainless steel. We see it as bonded plates. Bonded plates are of two types: explosion bonded and roll bonded. So generally, our client from the Middle East, they always ask for, instead of stainless steel, you go for the bonded plates, because with that actually they are getting the strength of the carbon steel, but they are getting the corrosion resistant of the stainless steel with the less amount of what they are actually paying for the solid stainless steel. So
Right.
with this is the new technological advancement that has happened in the plate. Then again, if I would say for welding, we have been seeing that there are been cases like weld overlay. I mean, where the space is quite less. I mean, if you consider like 30 ID of a pipe where we cannot even insert our hand, at that part, how they are doing the weld overlay, that FCAW, they have a long nozzle, and with that they are doing the weld overlay to provide corrosion resistant to the smallest part, so to extend the span life, because they don't want to even change that small part. So that kind of technological advancement we have seen in the industry. The challenges are few of them, I would suggest.
Yeah.
It is about the quality that we are procuring. See, the thing is, many of the US and Canada clients, they specifically ask that not to use mother hollow. Mother hollow is the after, based on the material from where the plate or the tubes are being manufactured. Even
Yeah.
the forging materials have been, I mean, the raw material for all of this. So this mother hollow material should not be procured from China or Ukraine. Basically, the Asian clients are using from the China as well as from the India. But if you consider about the quality, the material, if we say like 16 to 18% of chromium, it has to be 18% of chromium. But here there are chances that if we say in the batch wise, we may get it lower than what is prescribed for that particular grade. So because of that, the client is actually asking for to go for the mills that are present in Europe, US. Because of that, the timeline for the project increases, and that again increases the cost efficiency. Second is the machinability restrictions. uh, Being India is one of the manufacturing hub, other than the China in the Asian market, we have very much limited to the, I would say, the old technologies for machinability. Uh, particularly if I would say that I'll take an example. For heat exchangers, we use tubes. For tubes, we generally go for the vendors mainly have the draw bench as their machining. I mean, if I may explain it in a simple process, to manufacture tubes, Indian vendors as well as the Chinese vendors, they mostly use the draw bench, which produces very less as compared to there is one called Pilgard machine is generally with the Sandvik. Sandvik India has also procured, but they have very less amount over here. Mostly, if we want to have like say 1,000 tubes within the span of time, so this 1,000 tubes is been made in Pilgard machine very fast as compared to drawbench. Say if it is getting in 1,000 tubes in 1 month from Pilgard machine, for 1,000 tubes, this drawbench will take almost like 4 to 5 months. So the span time for the manufacturing of the components increases. Because of that, our overall, we can say, the project life cycle, I mean the commencing of the project increases. Hence the capital efficiency again increases. The client always asks for faster productivity. It is, I would say, current scenario after 2011. In between 2011 to say almost 18, it was very much difficult in terms of quality. We had procured stainless steel plates from Jindal as well as SR. But if you would compare it with Indo Steel, that is ArcelorMittal plant in Belgium, Indo Steel, the quality itself was stating that with the if we compare the material test certificate, both varies very largely. I mean, there was great variation. I mean, if we want a chromium and nickel to be of that, so here we were not getting of that. I mean, content, the chemistry. So
Right.
because of that, we were actually procuring it from the outside India. I mean, we were exporting it. But now I would say the Jindal has opened up their new plant in the Orissa, as well as the SR Steel has been changed the management. Now it is AMNS again, ArcelorMittal Nippon Steel. Both are the very much reputed steel plant. I mean steel manufacturers. So now the grade has been opened, and the people, even the client from the US, Canada, are asking that okay, you can procure the plates from them. Otherwise, it was purely restricted not to procure. So that
Okay.
was one of the challenge that we faced for procuring the plates. My focus is on the plates and pipes is more because they are in the huge quantity as compared to forging, and they actually constitutes the long lead items for the any project, if we say. Nowadays, we are working on the projects which are very much sustainable. I mean, green hydrogen is one of them, then the renewable diesel is one of the emerging demanding plants which have been installed in the Western countries, as well as
Yes.
the carbon capture unit, CCS. So, here we use the stainless steel to the much higher extent, and the we all, because again I would say it is costlier, that becomes itself a client, as well as we are very much conscious that material is very costly. We have to be very much optimized in the usage as well as the wastage part. If we
Right.
say again, I would be giving an example regarding the plate rolling. Earlier we used to have almost like 350 on the each side of plate was going to the wastage because of our limitations of the rolling of the plate. But now our roller, I mean that rolling machine has been developed in such a manner that only 75 on each side is being I mean taken as a wastage. Rest other, it has been developed as a rolled product. we are very much conscious about the reducing the wastage. So that's how we are basically looking at the sustainability and the less wastage. And yeah, again that is being sent to the recycling plant. So again that can be reused. Stainless steel components, if I would say, even in the terms of equipments, which are generally been exposed to the atmosphere as well as rain, snow, majorly all the equipments have been not been painted, but few of the equipments, because of the temperature service, they have to use the paint. Because of now, if I would say maintenance for stainless steel comes with the two parts. See, once if it is been started rusting, we have to replace that, or we have to do the pickling and passivation. Pickling and passivation is the term, say that kind of using the acid to clean the rust part, and again it would had the finish of like a new equipment. So that we do. Again the paint is generally not been there. So with this, using the stainless steel equipments, there is no usage of paint. So there is actually hardly a time during the, I would say, maintenance turnaround time, that is being taken as a breakdown time in the plant during maintenance tech. So with this usage of the stainless steel, that's how been, I mean, it has been mitigated. I would say that because now our very much we are into the sustainable fuel. I mean, even our crude has been fraction. Earlier, our process was very much crude. I mean, the kind of, if you have heard BS6 diesel that is been used in our new cars. I mean BS6 engine. So
Yeah.
this terminology itself says the octane number, how much, I mean, how much purity they want of that petrol or their diesel. So
Yes.
this is been done generally with the help of the changing of the process, changing of the temperature, pressure. They change the process parameters, and then the material part comes into the picture. Generally, if I would say the austenitic stainless steel, what I have the grade I have told you, that SS304 and 316 was generally used, but because of this of high elevated temperature, different parameters, there are many grades that has been involved. If I would again suggest that SS304H, now, it is not generally used. It is used only at a very high elevated temperature like 450 to 500 Celsius. Generally, at this temperature, SS loses its ability of chromium oxide, and they fine tune with the chromium carbide, and the rusting starts. But because of this SS304H, the higher carbon component is used, and that gives the strength at that temperature. Again, I would say the new SS metal grades, that is SS321 and 347, that are being told as like thermally stabilized stainless steel. It has been used better than, they have a better corrosion resistant than SS304. These are the new developments that is going on. I mean, the client is now preferring to use this because they increases the lifespan of the equipment. So that kind of innovation that is happening. Again, if I would say in the Kent PLC, we are looking to have to provide the cost efficiency to the client. At the end, the what matters to the client is more is about the money and the time frame. I mean, at what time they are going to change the equipment. See, if normal equipment stays for 20 years, this the material what we are expertise into, we provide that suggestion to them. With that, there is a very, we have an arbitrary calculation with us. With that, we provide that this equipment will be going to run for 40 years or say 50 years. Based on that, okay, we are in the technological advancement that using this technology with this thing or this material, particular grade, we can save this much of millions for you. So that's how we are into the job. Same here. Thank you.